Hi guys, maayong adlaw. Welcome to NatzMath TV. So for today's video, my presentation is about finding the nth term of an arithmetic sequence. This is still a topic from junior high school mathematics for grade 10 students. So before I proceed, in my previous video, I had presented to you the definition of an arithmetic sequence. So what is an arithmetic sequence? Again, an arithmetic sequence is a sequence in which each term after the first is obtained by adding a constant number called the common difference. In this case, the common difference is represented by small letter d. In my previous video, I had presented to you about how to find the common difference of an arithmetic sequence. So I hope you already have watched that video because that would be very helpful in our discussion about arithmetic sequence. So to proceed, an arithmetic sequence or the nth term of an arithmetic sequence is defined by this formula. That is, a sub n is equal to a sub 1 plus the n minus 1 times the d. Here, as I've said, the d is called the common difference, where our a sub 1 is denoted as the first term, that is denoted by the subscript 1 here. A sub 1, that means first term. A sub 2 is second term. A sub 3 is third term, and so on. And the nth term, which is a sub n, is of course our nth term or the last term. And of course, our d is called the common difference. So again, I already have a video about the common difference, so better watch that video about finding the common difference of an arithmetic sequence. So before we proceed to our example, let us review first about determining an arithmetic sequence. So how do we determine an arithmetic sequence? For example, we are given the sequence 2, 5, 8, 11, and 14. Then we have here ellipses, that means this sequence is an infinite sequence. But if we are going to determine if this sequence is arithmetic sequence, if we have remember, in determining an arithmetic sequence, we just simply check the common difference. If we have a constant number called the common difference from each of these terms, therefore this is an arithmetic sequence. So therefore, how do we find a common difference? So we just simply subtract 14 minus 11, which is 3, and 11 minus 8 is also 3. So we have 3 here and we have another 3. So they are constant. So if we are going to proceed, 8 minus 5 is still 3 and 5 minus 2 is 3. That means the common difference is 3, and since we have the constant number called the common difference in this arithmetic sequence, that means this sequence is an arithmetic sequence because we have the common difference, which is 3. So let's proceed to our next example. For example, we are given the sequence negative 5, negative 10, negative 20, and negative 40. As you have observed, there are no ellipses after the last term, negative 40. This means that this sequence is a finite sequence. Now, to check if this sequence is arithmetic or not, we have to determine if we have a constant number called the common difference by subtracting the last term, which is negative 40 minus negative 20. So negative 40 minus negative 20 is equal to negative 20. And another, so this is negative 20. Then negative 20 minus negative 10 is of course negative 10. So in this case, we have negative 20, negative 40 minus negative 20 is negative 20, and negative 20 minus negative 10 is negative 10, in which case they are not constant, meaning this sequence is not an arithmetic sequence. So if the difference from each of the term are not constant, meaning they are not equal, that sequence is not an arithmetic sequence. Another, we have 5x, 7x, 9x, 11x, and 13x. Again, this example is an example of a finite sequence because it has no ellipses after the last term of the sequence. So, to check if this is an arithmetic sequence, we need to subtract 13x minus 11x, that means 2x. So, that is 2x. Then 11x minus 9x is still 2x. 9x minus 7x is 2x, and 7x minus 5x is 2x. So, meaning we have the constant number called the common difference, which is 2x. So that means this sequence is an arithmetic sequence. Now for the last example, we have 1, 3, 6, 10, and 15. And we have 3 ellipses. That means the sequence is an infinite sequence. So to check if this is arithmetic, we have to subtract 15 minus 10 is 5. Then 10 minus 6 is 4. So this means we have 5 and 4. That means this sequence is not an arithmetic sequence because the difference is not constant. We have 5, we have 4, then 6 minus 3 is 3, then 3 minus 1 is 2. So this means this is not an arithmetic sequence. Okay? So to proceed, we have example number 1, finding the nth term of an arithmetic sequence. Example number 1. The first term of an arithmetic sequence is 200 and the common difference is negative 10. You are to find the 20th term of the given sequence. Okay? So first things first, since this is a problem, we need to identify what are the given. So, our first term, it is given. The first term of an arithmetic sequence is 200. That's why we have a sub 1 because as I've said, a sub 1 denotes the first term. A sub 2 is second term and so on. So, our first term is 200. And we are also given the common difference which is negative 10. So, we have our d is negative 10. And we are to find the 20th term which is a sub 20. A sub 20 since you are to find the 20th term. This is supposed to be a sub n. And since we are going to find the 20th term, so that's why we have a sub 20. Of course, in this case, our n is 20, which is the 20th term. Now, for the solution, of course, we have to use this formula. A sub n is equal to a sub 1 plus n minus 1 times the common difference, which is the small letter d. Then since we are going to solve for the a sub 20, so we need to substitute a sub 20. Instead of writing a sub n, we change that with a sub 20. And our first term, which is 200, that's why we have here 200, we copy the plus, then we copy the parentheses, then our n is 20. N is equal to 20 minus the constant 1. Then our d, which is the common difference, is negative 10. That's why we have here negative 10. I enclose this value for d in a parenthesis to indicate that the operation is multiplication and not subtraction. So in this case, we have substituted this value to the formula. We have to simplify first the terms inside the parenthesis. So we have 20 minus 1, that is 19. We copy 200, we copy negative 10. Then afterwards, we multiply 19 times negative 10. So that gives us negative 190 because positive times negative is negative. Then 200 minus 190 is of course 10. So our 20th term given the sequence is 10. Proceed to example number 2. This time we are given the first term of an arithmetic sequence is negative 5 and the common difference is 3. You are to write the first 5 terms of the sequence. Okay, this time we are to write the first 5 terms of the sequence. We are given the first term which is negative 5 and the common difference is 3. That's why we have here a sub 1 is negative 5 and the d is 3. And since we are to write the first 5 terms of the sequence, and since also we are already given the first term, so we are given the first term which is a sub 1 is equal to negative 5. So there is no problem with the first term. So let's go directly to the second term which is a sub 2. So how to find the second term? Since our first term is negative 5, we just simply add the common difference 3 to the first term. So since our first term is negative 5, so that is negative 5 plus 3, which is the common difference. So negative 5 plus 3 is of course negative 2. So if our first term is negative 5, our second term, which is a sub 2, is negative 2. So we now have the first term and the second term. Let's proceed to find the third term. Since our second term is negative 2, so to find the third term, which is a sub 3, we just simply add the second term, which is negative 2, plus the common difference is 3. So negative 2 plus 3 is positive 1. So our third term, which is a sub 3, is equal to positive 1. Now, we already have first term, second term, and the third term. We proceed to find the fourth term. So to find the fourth term, we just simply add the third term, which is 1, plus the common difference, which is 3. So 1 plus 3 is 4. Therefore, our fourth term, or the a sub 4, is equal to 4. And to find the fifth term, which is the last term for the sequence, so we have a sub 5. We have our fourth term, which is 4, plus the common difference, which is 3. So that gives us a sub 5 is equal to 7. So therefore, our arithmetic sequence, given our first term negative 5 and the common difference is 3, so we have negative 5, negative 2, 1, 4, and 7. So this is now our first 5 terms of the arithmetic sequence. Now let's proceed to the third example. Find the 14th term of an arithmetic sequence: 5, 7, 9, and so on. So this is an infinite sequence. But since we are going to find the 14th term, so that is a sub 14. Now, before we can find the a sub 14, we need to identify first what are the given. In this case, our a sub 1, which is the first term, which is given here, which is 5. And the common difference is 2. So how did we get the common difference? We just simply subtract. 9 minus 7 is 2. 7 minus 5 is 2. So therefore, our common difference is 2. Then, our n is 14 since we are to find the 14th term. Of course, our a sub 14 is unknown. So for the solution, again, we use the same formula. A sub n equals a sub 1 plus our n minus 1 times the common difference d. We will substitute a sub 14. Instead of writing a sub n, we write a sub 14. Then instead of writing a sub 1, which is the first term, we write 5. Then instead of writing n, we have to write 14. Then minus the constant 1 and our d, which is 2. Then simplify first the terms inside the parentheses. So 14 minus 1 is 13. We copy a sub 14 equals 5 plus 14 minus 1 is 13. Then multiply that with 2. So that gives us 26. And add 5 plus 26 will give us 31. Therefore, our a sub 14, or the 14th term of this sequence, is 31. So if we are going to continue writing the terms of this sequence, our 14th term will give us 31. Okay, proceed another example. Example number 4. In the arithmetic sequence, negative 7, negative 4, negative 1, 2. What term is 44? This time, we are given the last term, which is 44. So what term is 44? So let's identify what are the given. First term, a sub 1, of course, that is given in the problem, negative 7. The common difference is 3. So how did we get 3? We subtract 2 minus negative 1 is positive 3. Then negative 1 minus negative 4 is positive 3, and so on. Then, our a sub n, this is a sub n, which is the last term, is 44. We have a sub n because we do not know what is our n, because that is our unknown. So to solve solution, our formula a sub n is equal to a sub 1 plus n minus 1 times d. Substitute. Now, our a sub n this time we are given, which is 44. That's why we write, instead of writing a sub n, we write 44. Equals, our first term is negative 7 plus n is unknown since we are going to solve for n, minus 1 times the common difference, which is 3. Now this time, since we cannot subtract n minus 1, we just simply substitute, or we just simply distribute 3 to the terms inside the parentheses. So that is 3 times n and 3 times 1. So this becomes we copy 44, we copy negative 7. 3 times n is of course 3n. 3 times negative 1 is negative 3. This time we combine like terms. We can combine negative 7 and negative 3. So this becomes negative 10. Since this is now constant, we use addition property of equality so that this will be transferred to the left side. So we add 10 here, and of course we will also add 10 at the left side. So that becomes 44 plus 10, and this is plus 10, so negative 10 plus 10 is cancelled out, which is 0. So what remains at the right side of the equation is 3n. Then we add 44 plus 10 is 54. Then since we are only going to solve for n, we have to eliminate the 3, which is the coefficient of n. So therefore, we divide both sides of the equation by 3 so that we can cancel out the 3. What remains at the left side of the equation, or we can interchange this one already, so that is n equals 54 divided by 3 is 18. So you can write n equals 18 or 18 equals n. So therefore, 44 is the 10th term of the sequence with pH. Let's proceed to example number 5, which is our last example. The 16th term of an arithmetic sequence is 48. If the common difference is 3, find the first term. This time, we are told to find the first term. Okay? So identify what are the given. Of course, our a sub 1 or the first term is unknown since you are told to find the first term. Next, our common difference is given, which is 3. A sub 16 is 48, which is the 16th term. And of course, our n is 16. Now, for the solution, we use the same formula. A sub n equals a sub 1, then plus n minus 1 times d. We substitute the values to the formula. Our a sub 16 or the last term is 48. That's why we have here 48. Then since our first term is unknown, a sub 1, so we copy a sub 1. Plus, the n is 16 here, and minus 1 times the d is 3. This time, we subtract 16 minus 1 is 15, then multiply that with 3. So that gives us 45. Then this time, we use subtraction property of equality so that we can cancel this out. We subtract 45 here. Of course, we will also subtract 45 at the left side of the equation. So that gives us 48 minus 45 equals the first term. So therefore, our first term is 3, or you can interchange, you can write a sub 1 equals 3. So the first term for this given sequence is 3. Okay, that's it. I hope you have learned something from this video. More videos soon about arithmetic sequence. Next video is about arithmetic series, finding the sum of an arithmetic sequence. So for now, do not forget to subscribe and like and share to your friends. Thank you and God bless.